With the rapid development of distributed photovoltaics, photovoltaic fire accidents have occurred frequently due to issues related to product quality, installation, and O&M and regulatory standards. In response, solutions such as AFCI, module-level shutdown devices, and microinverters have emerged in the market. What are their functions and how do they differ from each other? An AFCI is a circuit protection device that identifies characteristic signals of DC arc faults through arc noise. Before an arc fault develops into a fire or a short circuit occurs, the power circuit can be disconnected to eliminate the arcs. Note that if the AFCI is triggered and the inverter shuts down, the DC terminal can be disconnected from the AC terminal, but the entire module array and the DC cables remain in the high voltage state, posing a risk for rescue operation. A module-level shutdown device is a device that allows a fast shutdown at the module level. During emergencies, modules can be quickly disconnected remotely or manually, resulting in the system voltage being equal to the open circuit voltage of the module. This can eliminate the risk for rescue operations, but the fire risk due to DC high voltage arc fault persists during system operation. Microinverter systems feature module-level input design, eliminating voltage superposition between modules. With a DC voltage of less than 120 volt, this can fundamentally eliminate the fire risk due to DC high-voltage arc fault and risk for rescue operations. To sum up, the main function of an AFCI is to detect and extinguish DC series arcs. A module-level shutdown device eliminates the risk for rescue operations by disconnecting the modules, and a microinverter possesses the inherent advantage of no DC high voltage, which can fundamentally guarantee the absolute safety of the system.